Okay, so just so you guys know, I'm going to skip over the first part of what this lesson would be, which would be I put these two problems on the board and ask everyone to kind of tell me what they think the differences are or how they think we might solve them, and kind of do like compare and contrast for the first like 10 minutes or so. So we're going to move on to just kind of solving them at this point. So as we all remember from last class, we know how to solve these types of problems, right? So what's the first thing we're going to do here? Bill?
Move the 7 over by adding 7 to both sides.
Yep. So what do we wind up with? Someone else. Abby?
3x equals 15.
Okay, so what do we do next? Caesar?
Divide both sides by 3.
Exactly. Okay. So what we wind up with is x equals 5. So that's called our solution, right? So now we're going to go on to this next problem, and here we're going to have an inequality. So the way we read this is 3x minus 7 is less than 8. Okay, so do you guys think we're going to solve this the same way?
Yes.
Yep, so we're going to follow all the same steps. So what was the first step we did over there?
Add 7. Do 7.
So we add 7. And again, now we're just going to read it as 3x is less than 15. So then again, we follow the same exact step and we divide by 3, right? So now we have x is less than 5. So what difference can you guys tell me about these two solutions? Nina?
One has 2 solutions.
Which one? So it does have 2 solutions. Does it also have more than 2 solutions?
Yes.
Yeah, this has an infinite number of solutions. So there's a different way that we can represent this, and it's not just by writing it out as x is less than 5. What we have to do when we have solutions like this is we have to graph them. So what we do for that is we're going to use a number line. So these are pretty simple. They could be drawn out. Sometimes they might be on your worksheets already. For this lesson, I don't want to have the number lines because we have to know how exactly to number the line, like appropriately for our problem. So what do you think would be appropriate numbers around the number 5 to put on the number line?
Like 4, 3, 2, 1.
Yeah, so we could start at 5 in the middle and then go down to 1. So 4, 3, 2, 1. But then we also want to go in the other direction. So we're going to go up to 6, 7, 8, 9. So here we have x is less than 5, right? So what that means is we're going to have an open circle at 5. We're not including 5 in this answer because if we include 5, up here we'll have 3 times 5 minus 7 is less than 8. And then that works out to be 15 minus 7 is less than 8. So we have 8 is less than 8. Is that true, guys?
No.
Right, so we need to include all the numbers that are less than 5. So less than, we move to the left. So we're going to highlight or mark over this entire region, including the arrow, because we have to go all the way to negative infinity. Okay? Because any of these numbers that we plug in will solve that problem. So now we're going to move on to the classwork. We have a couple of problems here that follow the same pattern. So I just want to do this to show you guys that it really is everything we've already learned, just applying a slightly different concept. Okay, so does someone want to walk me through the first problem? John?
Would you add 3 to the other side?
Yep.
Just get rid of the negative 3.
So if we can do that in this problem, can we also do it in this problem?
Yes.
Yeah. Oh, sorry. I don't know why I apologize to the board. Um, so we're going to add 3 in this problem to both sides as well.
So should the sign just be considered like an equal sign for this purpose?
We're not going to say it's an equal sign because if there are problems as we go down the page here where we do include an equals, because if we say it's an equal sign, then you might start thinking it means they're equal, but really this is less than, but it acts as a placeholder to say we're going to wind up with the solution at the end. So we're going to have 4x is less than 12. So again, it's all the same steps that we've already done, except this symbol in between is just slightly different. So what was our next step? Bill?
You should divide by 4 to get x1.
So we have x is equal to 3, and again, we're going to do the same exact thing, but with this problem. So we're going to divide by 4, and we'll have x is less than 3. So does someone want to tell me how to set up our number line for this problem?
So it'd be like, you know, the underline would be a circle, whatever. So it'd be 3 down.
So at the 3, you said we do.
You draw this a circle, and then you go facing, going down.
Yeah, so we're going to move to the left. So we're going to number these generally because we want to know the numbers surrounding 3. Hopefully you guys know those numbers, but just in case. And you want to go to the left and to the right. So can we also put this solution on a number line?
Yeah.
How do you think we would do that, Abby?
I think you could set up the number line basically the same way you have here with 1 through 6 as dashes, and then instead of having an open circle on 3, it would just be one solid circle on 3 and no arrow.
Yeah, so if we have anything that includes an equals, we use a closed circle, it's called. So our answer here is just 3. Do we have any questions on this so far? So moving on to the second problem. Does anyone want to read this problem for me and tell me what it says?
Negative 3x plus 2 is greater than 8.
Yeah, so this is a greater than symbol. That's great. So again, we're going to solve both of these problems the same way, but the difference is at the end the number of solutions we'll have and which direction and how many solutions are included. So who wants to start solving both of these problems? Besides Bill. Caesar?
Subtract both sides by 2.
So what do we wind up with?
Negative 3x equals 6.
Yep. And then what's next?
Divide by negative 3. X equals negative 2.
Yep. So when we're ever working with negatives, you want to be careful. Make sure you don't forget them somewhere, because there's a difference between x equals 2 and x equals negative 2. If you put x equals 2 on, as an answer on a test or a homework assignment, it's going to be wrong. So always make sure you're keeping track of all your negatives and you don't lose them. So again, we're going to start by doing all of the same things with this problem, right? So we're going to subtract 2 from both sides. And we're going to wind up with negative 3x is greater than 6. But now we have to do something that we haven't done yet. We have to divide by a negative in an inequality. So does anyone think they know what happens when we divide by a negative? Abby?
You change the greater than sign to a less than sign.
Exactly, and we'll show that when we check our answer here. So we divide by negative 3, so we know it's still going to be x something negative 2, but like you said, instead of a greater than sign, it's going to be a less than sign. So we're going to draw our number line again, and we're going to start at negative 2. And what numbers do we think would be appropriate around negative 2? Yeah, so -1, which is to the right of -2, because it's closer to 0. And then in the other direction, we're going to go with the -3 and -4. So again, do we have an open or closed circle here? Yeah, open. And then we're going to go to the left. Because again, it is less than. So we want to check this and make sure our answer is right? So let's use, how about -3 in this problem? So where are we going to plug -3 into this inequality?
Plug it into x.
Yep. So we take -3, multiply it by -3, add 2, and then is greater than 8. So what's -3 times -3? Yes, +9. Negative times negative always gives us a positive. Plus 2 is greater than 8. And what do we wind up with here?
11 is greater than 8.
So that's true, right? If you have $11, it's definitely more than having $8. But let's just try it with one of these other numbers just to see how our answer works out. So how about we use 0? Because 0 is always easy. If you multiply anything by 0, what do we get?
0.
Yeah. So we have -3 times 0 plus 2 is greater than 8. So we have 2 is greater than 8. Is that wrong?
Yes.
Right. So that's just showing that we have to flip this inequality anytime we deal with a negative sign. So does anyone want to volunteer and come up to the board for our third problem? Abby?
Am I doing just the one with the equal sign?
No, let's have you do both. So you'll notice here, guys, that I didn't use x, I used y this time. All that means is we could use anything as our variable. If you wanted to, you could use the word horse as your variable, but we're going to use y in this problem. You'll notice in some of the other problems, instead of using x, I also used a z. Okay, so Abby got y = 2 for this first problem. Does everyone see how she did that? Do we have any questions? Okay. So you want to do the second one, and then we'll have someone else come up and graph the number line. Thank you. Okay, so who wants to read this off for me? Bill?
Just the answer.
Yeah, and then you can come up and graph it.
Okay. Y is less than or equal to 2.
Yep. So what do you guys think? What do you guys think it's going to be, an open circle or a closed circle?
Close.
Bill, do you agree?
I do agree.
All right, good. We're all in agreement. Thank you. All right, so does everyone see this? We have a closed circle at 2, and then because it's less than, we're going to the left here, okay? So for our next problem, we're going to deal with fractions. You guys have dealt with fractions before. They're really not that bad, even though you all like to think they are for some reason. So we have 2/3 z minus 5 equals 9. And it's the same over here, except we have is less than 9.